Hello and welcome. I'm Shadow of Shadow Gaming, bringing you episode 18 of Programming with Shadow. In today's lesson, we're going to be looking at the IEnumerable interface. So last time we looked at interfaces and how you can use them to say what, or say that this class implements an interface, and that tells you something about some functionality. We also looked at some of the .NET ones. We looked at comparable and equatable. Another .NET one here is IEnumerable. That's what we're going to look at today. So, to begin with, we're going to need to think about what an enumerable is. So we've looked very briefly at a foreach loop. So let's make it an array. Let's do it a list. Int equals 1, 2, 3, 4. So with a foreach loop, for each int I in ints, we can do console.writeLine, and there we can loop over that. What lets foreach do that though is the enumerable interface. So can't really see it from here, but it lets you loop over collections, loop over data, and you tell it what you're looping over with implementing IEnumerable. Let's do that. So what we're going to do today is something called a Fibonacci sequence. Let's just do the sequencer so you know what it is. Let's do int a equals 0, b equals 1. So I'm trying to think how I want to do this. Those are the starting points. So let's do console.writeLine. Hey, let's do write. And we'll add a space afterwards. This is to make it more readable. Add a space. There we go. There's just a little bit. So the sequence builds up like this. So each value next will be the each value beyond this will be the previous two combined. So let's do while. Let's do a count. Yeah, count equals. I want to do 12 because I think that's the number I want to deal with. Let's do count. And I guess we'll need a int index I equals 0. Should just use a for loop here probably. Probably should. Yeah, let's do for int I equals 0, I less than 12, I plus plus. So each time here, it's going to get a little bigger. So next value, do int next equals a plus b. And that's how the sequence is going to build. Each time you'll just add the two together. So console.write next console.write space, then a equals b, b equals next, and then repeat. At the end here, we'll add a console.writeLine. Let's see if this works. I think it will. Yep, there's a sequence, but we don't want to make or stop it. I'm stopping at the one at 100. So it's 12 if you count the first two values. So those first two are called the seed values. So if it was just started with both of them 0, the sequence wouldn't be too interesting. Or that sequence will just keep going and bigger and bigger. And you can see here that it doesn't take that long to calculate. So this is a good example of a program that you can do recursively, but there's a problem and it'll end up you only get so far before it gets really big. The way you can solve that is through enumerables. So this is a sequence that's just building up a pattern. That's what enumerables are really good at, are sequences. Or otherwise. Let's do just put a 30 here just to see some big numbers. We'll get an overflow pretty soon if we don't hear. Yeah, not even close. We'll keep it at 10 because you can see the pattern's pretty easy to follow. It's just the previous 2 equals this one, and the previous 2 equals this one, previous 2 equals this one, and so forth. There's just a pattern. All right, so let's do this. So let's let's make a class and implement it. Yeah, let's do that. Let's do that. I'm just going to do it here in the same file for now. We might move it later, but let's do public class, and let's call it Fibonacci. I think I spelled Fibonacci right. If I didn't, I'm sorry. So we're going to do 2 interfaces. IEnumerable int. We'll start with that one. If we do here, let's see what it tells us. We implement the interface. We have a get enumerator and a get enumerator. These look similar, but the first value here is different. What this is saying is if you call the class with the method, this is the one you'll do. If you call the interface with the method, this is the one you get. And as you see, it's just pointing to this one. So this is just the way you do it, but not technically all that impressive. In fact, to even make it even better, I'm going to say it's this because we're going to IEnumerator as well. If I can hit the right button, control dot, not control colon. So now we have a reset, we have a get enumerator. Doesn't it like this? Oh, return this. I mean, am I doing this right? Let's see. I'm a little confused on that. See. Let's make this a expression body member as well. I'm putting these over. I tested out the example, and this should have worked, I thought. Let's go ahead and implement the rest of it and see, but it should have worked. Let's do, let's see. Let's have the same values. So these are to be the seat values. I'm using underscore because these are just private variables. So private. These are just local ones. Private int current private full started equals 5. So do public int current. That's current. This one's a private object. Current. It's a IEnumerable. IEnumerator. And we'll just have it return current as well. There we go. I'm confused by this one. It should have been fine with that. Oh, we need one more method down here. I'm not going to do anything with that one. We're just going to pretend it's here. You can see it has a warning, and it doesn't look like it does anything. It's just needed for the format, I believe. I'm really confused on this one. Oh, it's a typo. Should be IEnumerator. Yeah. I didn't tell it what type we're actually dealing with. There we go. So if you see that, go back. You can tell I wasn't used to seeing that either. An explicit conversion exists, or you missing a cast. So what that's saying is that the types here don't match. I've got it as an enumerator, but I don't have the type of the enumerator, so you would have to cast it. If you use the generic one, int here, then it's handling it yourselves. As you can see, I was not expecting that to get that error out. Here's what we have. We're not going to support, instead of not implemented, let's throw not support. Yeah. So we're not going to allow reset on this. So once you do your sequence, you've done your sequence. No restarting. I guess we could restart and we could just say underscore a equals 0, underscore b equals 1. I think that would restart us, but not 100% actually. I don't think I've ever actually used restart, so might be a good time to play around with it afterwards, but let's just throw not supported for now. We'll come back to it. Move next, here's the important one. So when you get an enumerator, so what it does is it'll keep calling this move next function until it either ends or you've called it as many times as you want, or there's some ending. So what we're going to implement here is that. So if not started, then current equals first value, and started equals true. We can return true. If I can spell. It's going to be one of them days. Next equals underscore a plus underscore b. A gets b. Underscore b gets next. So this is just doing that same thing we did before. We're building up the Fibonacci sequence. A gets b, b gets next. Then I'm going to say current equals a. And that's the value it's going to retrieve at each time, is whatever's in current. And current just calls the private variable here. We could probably do that with a private set and use an auto property actually. We might do that actually and make that change as well. Let's do return true. You notice there's no path where we return false here. That's because it's not really needed. Go implement this one. So here's our previous one. So now what we can do is we can call this with a for each loop. In this case though, we never tell it when to stop, so for each won't know when to stop. So what we're going to do here, let's add a count. Int count equals 0 for each. just say fib and Fibonacci infinite. We need to create that actually. There we go. Click on top. So now we've got the count there. Let's say if count is, let's see, greater than, I think that'll get us the same value. So we could do it's less than 12 would be clear. So I think that'll get us the same count. So these two and then 10 other values. But we may have to adjust. So at that point we're done. We'll just break out because this one will keep going on us. Eventually we might have other problems with the value no longer fitting. Let's do console write. Console.write. Base, and then we'll do console.write line. So there we go. So let's see if these don't give us the same list. May not need to adjust that count. Go away. Why did it not go? Oh. Should be a while. So yeah, let's do it the other way. Let's do it greater than 11. If count is greater than 11. Yeah, I should have stuck with what I thought of last night. There we go. So there, the sequences look very similar. What happens if you pick back up though? So there we go. What if we do the next one? Console.write line. Let's do Fibonacci infinite dot move next. We need to do that separately. Be a bool, we don't care. We may want to do this the other way, but we'll see. Fibonacci infinite dot current. So let's see what the next value is. So prediction, it's going to be that 144. Yeah, it's right up here, 144. 233. So what happened? If we do console.write line ahead of time, so what you're going to see here is that it should match up like we expect. What happens is the move next happens either way. So when it's going through the loop, it'll hit the move. It'll do its own move next beforehand. There we go. So then us adding one just moved us past the value. But see, the sequence picked right back up where it was going. So we grab the current, we move to the next one, we grab the next current. While move next is true, it should keep going. If as we remember, there's no faults in here. It'll just keep building up if we wanted to. But there, we can do that. Let's see what else we can do. So let's try that reset. So I haven't actually tried reset, so let's see what it does. Let's do underscore A equals 0, underscore B equals 1. Are there any other default values? Underscore started equals false. All right. So let's see what that does, because I'm actually not sure. I've never actually done anything with this. So let's do Fibonacci infinite dot reset. Now current. Let's just do the same thing again. See what happens. All right, so it doesn't reset current, which makes reset current. So there, now we reset current as well. Now we should see 0 and 1. Need to move next one more time. Expect this one to be 0. Expect move next to move it to 1. Let's see what this does, but if this doesn't do it, I'm going to say I don't know how to use reset, and I'll look into that later. There's 1. But if we do it again, I bet we get 2. Let's just do that. Just for the sake of it checking. There's a couple more. Let's see what happens. I still don't know where the first 0 is coming from. I'll have to check that. But that does look like it reset, so there's us a reset. So let's copy instead of doing this, to I don't keep the first one. Copy everything from count here. Foreach. Let's copy the foreach and do it like this instead. We'll set count equal to 0 right beforehand. There we go. Now let's see what happens. It picks back up. Does not reset because I did not reset. So let's do Fibonacci infinite dot reset, and I think we should get a sequence that resets. Okay. Yeah, so that R actually looks right. So I guess you have to move next for the first value, which makes sense because it's not started. So I guess that makes sense. Let's come down here. So I said one thing we could do here is current here. This could be a property, so let's do that. Let's do get private set. Then we don't need current here. Now it's current. 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 And now this should be the exact same thing, but little more compacted, using a private set instead of a private variable. And it does the same thing. Good. All right. So there's this a very quick implementation of IEnumerable and IEnumerator. The key points here is this get enumerator. That's what you're actually implementing, so it knows what to do. And what it does is it calls this move next method and this current property. I guess it's calling this one, and it knows to call this one. But move next here just tells you what you're going to do, and what it does is returns true if it can keep going and returns false otherwise. And we added a reset because I didn't know what it did, but it does work, so good to know. Never actually had one of these that I've actually reset, so that's actually a first. So let's add another one. Let's do a second Fibonacci class. This one we're going to do differently. So this time we're going to have a stopping point. We're doing this to demonstrate how you can do that. So let's have a max value. Let's say Fibonacci value is up to 100. So if you notice, this value is the highest above 100. So that's the reason I was picking 12. So let's do that. So let's do public class Fibonacci up to value. something like that. IEnumerable int. Let's make sure I get the IEnumerate enumerator int. There we go. All right, so this one we're going to do slightly differently, but it's going to be very similar to the previous. So let's do this. So let's do private read only int max. We don't want to change max once we set it. Private int underscore a equals 0 underscore b equals 1. Private int. Yeah, let's not do current. Do bool started. We're also going to need to know when we're done, so we'll do private bool ended equals false, something like that. So here we're going to need to deal with the constructor. So let's do ctor. It's trying to do it for the main class, not this one. So if you do that in Visual Studio or Rider, it'll do the right thing there, but VS Code apparently not. So let's just do public Fibonacci up to value int max. I should say value there, but whatever. I'll leave it at this. So this is giving us a hint we can use something called a primary constructor. I haven't used these too much, but basically it lets you pull the value up here to the class, and it says, okay, this is the primary way you would use this. So I give this int max as a parameter, and here's how we use it. We set this value here. And I'm going to leave it as this because I haven't talked about that, but that's called a primary constructor, and it's the same thing as we just seen them there. Let's see, let's continue on. Let's do public int current get private set object IEnumerator current equal not equals expression returns current. All right, so now public IEnumerator. This is an int, the enumerator of the int. Get enumerator method. This returns this. I don't know if I've mentioned this. I think I have, but I'm not 100% sure. But this is a reference to the current class, so the current object. So it says this object, this class, this object, return it as the enumerator. We can do that because it implements IEnumerator. So IEnumerator equals IEnumerable dot get enumerator. We'll just call the other one public bool move next. So here, let's go ahead and fill the rest of the boilerplate. Void reset. So now we know it does work, but I'm not gonna continue with it. So if you need to reset it, that's what reset's for. Public void dispose. Spell dispose. So, here we got a warning. I don't think I've ever used this, but if you have something that's disposable, this is how you get rid of it. The idea with disposable, it's another interface. It's iDisposable, and it's if you have to clean up something like I guess a file. Like if you open a file, you have to close it. We've used read all lines and write all lines. If you need to do anything more than just that, you have to open the file, do your operations, but then you need to close it at the end. You can do something like that in dispose. I'm not going to look into them now. That may be a lesson in the future, but not now. But just that's what dispose is, and you may see that occasionally. So if done, we can return false. There's just a return false. What exists? Now, if started is not started, we need to initialize. We'll do current equals underscore a, started equals true, return true. Now, this will be very similar to what we did before. Next equals underscore a plus b. Now we need the condition if we're done. So, and that is if next is greater than max. So if we're greater than whatever the max value is, we're done. Let's say done. I'm saying done because that's what I thought of last night. So I'm using ended here. Equals true. Break out of the enumeration. Picking that the word break there specifically, we'll see shortly why that is. Equals b, return true. A plus a gets b, b gets next, current gets a, return. You can tell this is not what I did last night. All right, so here we can tell it when it's done. We say it's done. We make the current whatever the previous one was. The next is too much, so the current's the previous. Then we're done. So I think that's all we will need. So if we come back up here and use this one we don't need to. Here we were having the count and do the counting thing. And because it's infinite, this one's no longer infinite. Now let's do, I think how I want to use this one. Do Fibonacci to up to value. Fibonacci to value equals new. Let's say the value is 12. I think that gets us the sequence. Now we can just do for each int fib in Fibonacci up value console.write fib console.write space. I think that's all we need. There we go. So let's try this. Need to add a space somewhere. Right here. Did I do right? So it didn't go up to 12. So why didn't it do that? So what it did is I'm thinking value. That shouldn't be value. I'm thinking value is the number of things it returned. What it's supposed to be is 100. So let's see if this doesn't do it. We're saying up to 100. So being dumb with my method names, class names. There we go. Up to 100. So here, if we didn't have this, if we didn't do this counting thing here, this will run a very long time. Let's just run that just to show that. You're just going to see it's just going to start dumping text to my console, and you see it just looping back and forth around 0, positive values, negative values, and so forth. And that'll never end. That's an infinite sequence, so we can't do that. I should have showed that before, but I did not. That's why we have the count there. This one has a break in it though, so it's not infinite. So we say we stop when the value gets over 100. So there's just a little nice functionality here with IEnumerable. That looks like a lot of code to get just a infinite sequence here. In reality, it is. So that's the full actual implementation. Let's do another class down here. Let's call do the same thing. Let's do public class Fibonacci infinite 2. We'll come back to that. So let's have a method here. Public int. Yep, that'll do. All right, let's see if I can get this. Needs to return IEnumerable int. Yeah, it can be static. So let's do this. So we'll have the starting values: a equals 0, b equals 0. So notice I'm not putting the underscores. That's just convention. Private class level variables get underscores. Private method level variables do not. Or I equals 0, I less than count. We don't even want count. Let's do I don't think how I want to control this. Let's pass in count. This is going to be an infinite sequence, but I don't want it to be infinite. Yeah, well, let's see if we can't control it otherwise. Do new keyword yield return. Equals 1. So while true. So there we go. There's a scenario. Trying to think how I want to do this. Let's do it like this. So we're going to want to control this because this is going to do just like we did a minute ago and print too many. But let's see what we can do here first. Well, I want to do this. Wait a minute. Let's do it like this. Let's do it just like we did before. Int next equals a plus b. Turn next. We'll do it like that. There we go. Let's see if this doesn't do what I wanted. Now, this one's a little easier. So let's do foreach int fib in Fibonacci infinite 2 dot fib. We'll print this out. This should give us the big one that. There we go. Should give us the big one that's too big to care about and just keeps looping. Let's see if it does. I think this is going to be infinite. Infinite. Control C. So let's add the counter here. Grab a count. Do count plus plus. So if count is greater than 11, break. So here we should see this to be the same sequence. So let's see if it actually is. It is not. Oh, I need to handle the first one. Yeah, being dumb. Now let's go back to what I came up with last night. So here's what I came up with last night. And this makes sense. So here we print out the first value, which was 0. Then we make this 0. Then we get 0 equals 1. Then 1 equals 0. So then we have 1. B equals 1. Now it's a 1. 1. So I should have kept with what I did last night. There we go. There's just another sequence. We'll do the other one here as well. Public class Fibonacci up to value 2 int max. So private. Let's not do that. Wait a minute. I don't think I need that. Let's do public static IEnumerable int fib. And it needs to take max. So now do the same thing. Int a equals 0, b equals 1, while true. So same thing. If, here's our stop clause, a is greater than max, yield right. There's just another new word. So then we'll do yield return a. Int temp equals a equals b equals temp plus a plus b. There we go. There we go. There's our second one. We can make sure it works. Find our code here. Foreach int fib and Fibonacci up to 2 dot fib and do 100. But now let's just do the same thing here again. And we should see that this ends up with the same value. So right line. I'm just doing that to add spaces so it doesn't put it on the same level, so it doesn't overwrite my prompt. Now we should see the same sequence. There we go. 4 different ways to do the same sequence. So this yield true or yield return is doing the same thing as this move next and current. Notice we don't actually implement the interface. That's because it's done common enough that that they added the keywords here to do it for you. And what those are doing is returning the next value of a sequence. I have multiple yield returns in something and just the next value. So if I had another yield return down here, it would still work. It would just be the whatever value returned, and then that would be the next one. And each time it gets to a yield, it waits until it needs the next. So if you stopped your loop there, you don't need any more yield, so you're done. Break, on the other hand, says, okay, we're done with this enumeration, so get me out of it. Ends the enumeration for you, so you see the for each just ends while the other one kept going infinite. So there's just an introduction to IEnumerable and IEnumerable. Very brief one, but I think this is a good spot. It gets you started so you can think through it if you need to use it. And Microsoft's documentation should help you out on actually use this. Actually didn't. This is the way I've almost always done this, so I very seldom actually implement IEnumerable myself. I actually have one for one thing, but again, that one thing didn't end up including a reset, so This is what I used for reset, so I didn't even try to reset it, so I didn't know how that worked. Makes sense. You just have to reset the values, so that makes sense. But what's happening is it's calling move next and then gets the current value each time. That's sort of what's happening, really. At least I presume it's the same thing. But you can do a lot of neat things with these sequences because you build up on top of each other. Like you can have sequences of sequences. You can do interesting things with them. There's a real common library in C# called link. LINK. Stands for Language Integrated Query, LINQ, and it makes a lot of use of IEnumerable. That's what it's doing. Is it's giving you a different way to express an idea. So most of the things we do or we've done so far have been you say you do this, do this, do this, do this. That's called imperative. You're telling the computer what to do. Write this line out. Move this sequence to the next value. Write this current value. Reset. You're telling it step by step what to do. Link comes at it from a different perspective. You're still telling it what to do, but you're doing it indirectly. And that's called this is called imperative, the other is called declarative. You're saying I want this, and and Link will figure it out how to do it for you. And that can be really powerful. Some other programming languages do that. That's the goal for databases. There's a language called structured query language. It's intended to work similar to that. That can be a really powerful idea. We'll see it more of functional programming than object-oriented programming, but Link's just a sort of a move in that direction, and it makes a lot of use of enumerables. We may look at that in the future, but it won't be next. I think next step we're going to try to. We've learned quite a few things. Learned objects, learned inheritance. We've learned interfaces. We've looked at some of the built-in interfaces. We've looked a little bit at very start of data structures. I think it's time to pull back just a little bit. Let's see if we can't implement a project or two, maybe even a few, but implement a couple projects and put our knowledge together because we've covered a lot of ground. So I think that'll be the plan for next time is actually start looking in the project or two. So one thing I don't remember if I mentioned, but this is where I'm getting IEnumerable is from system.collect. That's one thing. Let's do a recap. So in this lesson, we've looked at how to use the sequences of values in C#. The implementation for that's called IEnumerable and IEnumerator. So the idea here is that we can do a for each and go for each value in the sequence, do something. Here we had to break out eventually. The other one here we told it when to stop, and we could stop it at that. This one. Then we looked at a little more built-in way to do the same thing, and then an even more compact one, and each one of them got a little better. So this was the first one. It implements two interfaces, these two here. These are the important bits, the current value, and then we get a numerator, so it's how it's going to loop through. What all that does is calls current and move next here, and we control move next. We also have access to a reset, which we can use the reset values here. Then a dispose that we didn't use, but we may end up using. Doing that, you're able to do sequences, and they can be arbitrarily long. Like it only calls it when it needs to call it. So as you're looping through, you get a value, and then it'll call the next one and call the next one, and it won't call an extra one until you actually request it. That can be really nice. That has really good benefits of if you don't need to compute it and it's going to take a lot to compute, you don't have to. So that's an implementation. Here's another implementation. This is basically the same thing. This is basically to move next method. It's all wrapped up into this yield return. And using that, we're able to do the exact same sequence. And seen me struggling just a little bit. I'm not as well planned as I'd like. This came fairly late last night to putting it together, but in general, it's not that complex. It's more of what are all the pieces and how do I put them together. But the actual complexity is not a lot. And I've used these quite a bit. I've not implemented IEnumerable and but that's just sort of the path you can go down. After that, we set a value, so some spot we end at, so we stop our sequence. Basically, just controlling the sequence. So this one looks exactly the same, except there's this little bit here about ended flag and end returns false. So we finally stop with the enumerator. And the other one of it was exactly the same thing. There's a keyword yield break, and it stops the enumeration when A is greater than max and a bet. So very similar. When I thought of this, I just thought through them differently depending on when I was doing it. Because this lesson's been hard to get together. It's been a busy week, so it's been one of them I've done a little bit here, a little bit there, and it's hard to put together. But I think this will be good enough, and it gives, even if you haven't followed the lesson, it shows you how you can start. You can use the Microsoft documentation to build up from there if you need to. And maybe a feature you don't need much of, because I've done quite a few of them, but I'm working at the project I work at, we've had a need of it. I could see cases where you never need something like this and might not come up all that frequently. But that's pretty much enumerables in a nutshell. That's a very brief, very, very to the point. Like, we didn't spend a lot of extra time. We didn't do a lot of experimentation outside. Did a little bit of experimentation, but not a lot. But we're gonna call it there. Next time, like I said, I think it's time to step back a little bit and let's try to actually implement some things. So maybe next few lessons it'll be some projects, and we'll take it from there. We'll see where this takes us. So this will be episode 18. So thanks for watching and have a wonderful day.